The next topic we are talking about today is radical equations. A radical equation is any equation with a radical symbol in it. So some examples are below. So the square root, or the cube root, or the fourth root, with an equal sign it makes it a radical, and the equal sign makes an equation. Okay, so that's a radical equation. Follow these steps to solve the radical equations. Step 1, isolate the radical symbol. Make sure it's all by itself. So on our first example, see how that radical symbol isn't quite all by itself? That minus 5 needs to get moved to the other side. On our second equation, again, the radical symbol isn't all by itself because there's a minus 1. That needs to get moved in order to do step 1. But in our third equation, do you see how the radical symbol that goes all the way over to the 4? So this one is isolated. So that would be step 1 would be done on that example. Get rid of the radical by raising each side of the equation to the index. Okay, for example, notice this one is a square root. So because we are trying to get rid of the square root, we square both sides so that it comes out of the radical sign. If it's a cube root, then you would cube both sides so that it comes out to be just the index. It's a fourth root, you're going to raise both sides to the fourth power so that it comes out and just is the radicand. Step 3, solve the resulting equations. Now some of your equations might be linear, which is easy to solve. You get the x's on one side, numbers on the other, and divide. But others may be quadratic, meaning you're going to have to use your quadratic skills from the past couple of lessons. Step 4 is not an optional step. It says you must check for extraneous solutions. Now, most of the things that we've done in the past have been optional checks. This is not an optional check whatsoever. An extraneous solution is a solution that is not valid, and they need to be discarded from the solution set. This often happens when we square both sides of an equation, which is what we're going to be doing a lot today, okay, when we square both sides on step 2. So you have to check your work. If there was a shortcut to this, I would show it to you. There isn't. You just have to work out both sides. So on our problem, step 1, is this radical all by itself? No, it's not. This minus 5 needs to be on the other side. So I'm going to add 5 to both sides so that the square root of 4x plus 1 is equal to 5. And now in step 1, my radical is all by itself. Step 2, raise both sides to the index. Well, this little index is a 2, so I'm going to raise both sides to the square. So the square and the square root undo each other, and I'm just left with 4x plus 1. That was kind of the whole point, right? On the other side, 5 squared is 25. And then step 3 says solve the resulting equation. Notice that this does not have any squareds on it. Because there's no x squareds, it's not quadratic. This is just linear. This is something fairly simple to solve. I'm going to subtract 1 to get all of the x's on the left and the numbers on the right. Then I'm going to come in and divide both sides by 4. And my solution is x is equal to 6. Great, this is my potential answer. I say potential because I have to do step 4, check for extraneous solutions. There is no shortcut here. I just have to check all of my answers. In this case, I only have one answer, which is nice. So I have 4 times x, but x is now 6, plus 1 minus 5 is supposedly equal to 0. I say supposedly equal to because I don't actually know if it's right or wrong. That's the whole point. I'm checking it. So that's why I put the question mark on top of it. It's not true until I show you it's true. So that's the square root of 25 minus 5 is supposedly equal to 0. Let's see, 5 minus, that does now equal 0. Excellent. So is 6 a good solution? It sure is. On our next example, we have the cube root, and then we're subtracting 1 equals 4. Is this cube root, the radical, where the radical stops over the 4, is that all by itself? Not quite. I need to add 1 to both sides so that it can be by itself. I'll get the cube root of x squared plus 4 is equal to 5. Now, is this radical all by itself? Now it is. Step 2 says to raise both sides to the index. Well, this index is 3 this time, not 2 like last time. So I'm going to cube both sides. The cube and the cube root undo each other. That was kind of the whole point, right? Is to get that x squared plus 4 out of under the radical. So 5 times 5 times 5 is 125. Notice that this equation does have a square in it. So this is a quadratic equation, which means we're going to be using another method. Now this looks like a square root method to me because there is no b term. So let's subtract 4 from both sides to isolate the x squared. It's 121. This is not the only way you could have done it. You could have set it equal to 0 and factored or quadratic formula, but I saw that square root method's going to work. So I'm going to get x is equal to, whenever I take the square root of both sides, I get the plus or minus part, 11. So these are my two potential answers, really negative 11 and 11, right? So I say potential because I have to check my work, not because I'm worried that you're not doing your answers correctly, but because inherent in this process, sometimes you get extra answers, and that's not your fault. So we have to check both of them independently. So let's do 11 first. The cube root of 11 squared, well, that's just 121, plus 4, then subtract 1 is supposedly equal to 4. So this is the cube root of 125 less 1 is supposedly equal to 4. The cube root of 125 is 5. Well, look at that. This one certainly does work. The 11 works. On the next one, I'll plug in negative 11. Negative 11 times negative 11 is positive 121. Here we get what? It's cube root of 125 less 1 equals 4. And look, it's the same as the original one up top, so that's 5 minus 1, which is 4. And they both work. That doesn't always happen. Sometimes one works, sometimes they don't. Okay, so you don't know, you have to do them all independently. There is no pattern there. If one works, the other one shouldn't. Nope, in this case, they both work. On the next problem is the radical all by itself. Again, no. So I need to subtract 6 from both sides so that my radical can be all by itself. Okay, that was step 1. Now my radical is all by itself. Step 2 says to raise both sides to the index. Well, my little index here is a 2. So I'm going to raise both sides to the 2 so that the square and the square root can undo each other, and I'm just left with the inside radicand. Negative 5 squared, notice I'm multiplying negative 5 times negative 5, which is positive 25. This one looks like square root method too, but just to give you a little variation, let's factor it. So we have x squared minus 9 equals 0. X plus 3, x minus 3. So I get positive 3 and negative 3 as my two solutions. So those are my two potential solutions that I think are going to work. I actually don't know if they're going to work or not. I have to go back and check each one independently. So let's try 3 first, and then we'll go and do negative 3. So I'm going to plug it in. So I have 3 squared plus 16, then plus 6 is supposedly equal to 1. That's 9 plus 16 is 25. 5 plus 6, is that 1? No. 5 plus 6 is 11. But it's only really off by a negative. If this 5 was negative, then it would have worked. And that usually is how it happens. It's only really off by a sign somewhere. But no, this doesn't work. So I have to eliminate that. Is this my fault? Did I do anything wrong inherent in my process? Well, no, I didn't. I didn't make any mistakes here. But just because when you square both sides, there's a potential that you get an invalid answer, that's why you have to check your work. It's not that I don't think you're doing it right or that you make mistakes a lot. is because you have to check your work to make sure that you don't have any extra answers. When I check the other one, negative 3 squared is still positive 9. And I get the square root of 25 plus 6 is supposedly equal to 1. And again, this is not equal to 1. This is bad news. So I have to take that answer out as well. So my two potential answers that I didn't make any mistakes on happen to be extraneous. That word extraneous, you see that word extra, means extra and not valid. So my answer is going to be no solution. Now on the last example, both of the two values worked. On this example, neither of the two values worked. There could be a case where one works and one doesn't, so please be a little bit careful and don't just assume that it's just always going to work or always not going to work.